This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Sam Taggart, and I'm here today with my guest, Jason C. McDonald. Jason is a software development manager, speaker, and the author of Dead Simple Python, among some other books. He's the founder of Mousepaw Media, which is an open source software organization where he trains software development interns. So Jason and I are here today to talk about something he's developed called Quantified Tasks, which is a replacement or alternative for story points. So Jason, let's start with talking about story points, what they are, where they came from, what people use them for.
Sure. Yeah, happy to be here, Sam. So story points comes from the Agile methodology. That is, it came out of the Agile methodology, specifically Scrum. And the idea was to be able to estimate how long it was going to take to accomplish a particular task or a release. As soon as I say how long, of course, all the Agile purists are screaming, no, it's not about time, which that's the goal, is it's not supposed to be about time. But in practice, when you implement Scrum, when you implement story point estimation in an organization, that is what it becomes about, because managers want to know how long is it going to take us to ship this code. So story points was devised as a way of measuring how much effort it was going to take to accomplish a certain goal, a certain task. But because we don't have something like inches or pounds or hours or some sort of handy metric that we can use to measure the size of a task, they instead decided to measure it kind of in the imperial way. If you think back before we had the standard metrics, everything was measured relative to something else, and usually the king's foot throughout Europe, ergo the imperial measurement of the foot. So story points is a way of measuring tasks relative to other tasks. So you come up with some fairly arbitrary scheme of numbers. You have one task, you give it a number. It almost doesn't matter what number you give that first task. And then you measure everything else in relation to that task. Is it bigger or is it smaller? Which is an interesting idea, but like with the foot in imperial times, it lacks standardization, it lacks repeatability, it lacks objectivity. As soon as you change kings, or in this case, teams, your measurements are suddenly very different.
Yeah, well, I remember reading the book, The Agile Samurai by Jonathan Rasmussen. I think that's the right author's name. And it had something in there where it talked about how, from psychology, we're really good at measuring, at looking at two things and telling which one's bigger, right? So that relative measuring we're pretty good at, but the absolute measuring of saying, okay, this one's bigger than that, but which one's, is this 1.9 and this is 2.1, or like what? It's a lot harder to do that.
Yes, exactly.
So I think that, yeah, that's some of the psychology behind it. So what scales do people usually use for these? Like I've seen all kinds of stuff from like numbers, Fibonacci sequences, t-shirt sizes. Have you seen anything else, or are those pretty much?
Those are basically, in a nutshell, anytime you're dealing with a numeric scale, what's preferred is something with some sort of exponential or at least nonlinear growth. That's why Fibonacci is so popular. And it's funny we say Fibonacci because it's not Fibonacci. It's usually a modified Fibonacci sequence where they add a number, they drop something. I can't remember exactly what, but they've modified the Fibonacci sequence to be a cleaner exponential curve. And it's the idea being that the larger the number is, the more distance there should be between that and the next number. The reason for that being, the larger the task, the more likely is there's something uncertain in there, something you don't know or you don't understand. So a difference between a task that'll take you 10 minutes and a task that's going to take you an hour, or between a Fibonacci 1 and a Fibonacci 2, is very small. But the difference between a task that's going to take you, and again, I know everyone's cringing that I'm using time here, but again, that's what it ultimately boils down to. A task that's going to take you a week versus a task that's going to take you 2 weeks, there's a huge difference between the two because you don't know what other things you don't know. You don't know what you don't know. The more complicated the task, the more effort involved, the more unknowns there probably are. Probably. Massive asterisk here, which is, again, where things get a little bit wibbly-wobbly, timey-wimey.
Yeah, when I always talk about estimates and stuff, I always try to plan on really short intervals. The shorter interval you plan on, the more certainty you can have.
Right.
Like if I wake up in the morning and say, this is what I'm going to do today, I can be fairly certain about that. If I say, this is what I'm going to do next week, well, there's a lot of time that passes between now and then. And a lot of, I could get interrupted. My plans could change completely.
Right. Short cycles being one of the key principles of Agile.
So my next question is, what do the current approaches fail to capture? Like you created this alternative. Why did you create this alternative?
Well, and I have to go off on a tangent briefly, too. When I created this system, I did not create it on the basis of replacing story points. In fact, when I created this originally, I didn't even know story points existed because I conceived of this while reading the book Dreaming in Code by Scott Rosenberg. Back during my first year as a software engineer, I read this book. And there was this remark in there by Scott Rosenberg that there are certain tasks which he refers to as black holes, which just suck up inordinate amounts of time. And it doesn't matter how much work you throw at it, it never seems to get done. And he said every project has one of these, more than likely. And the more of these you have in a project, the less likely the project's ever going to get finished. Most famously, in his book, he pointed to the disaster of the FAA trying to get a new air traffic controller system built that never did get built because it was full of those black holes. But he made an interesting remark that most software engineers can tell you whether or not a task is a black hole within the first 10 minutes of working on it. So that planted the seed in my mind that, okay, there's something about a task that we're capable of assessing. There is something objective here that can tell us whether or not this task can even be completed in a reasonable span of time, if at all. And so that began this process of me developing what would iteratively become quantified tasks. What became evident as I started working on teams that use Scrum, that use story points, was that what story points was failing to capture was not only this probability that the task was a black hole, it was being sort of indirectly captured by the size of the Fibonacci number, but not reliably. Maybe that 8 is a black hole, maybe not. Like those numbers, all of this thought was going into them. I was hearing all these conversations about, oh, well, there's a lack of documentation on this, or, oh, that code is really bad, or, we're not sure how this particular technology works, or that requirements document isn't fully finished. So there's all these factors that were going into the sizing conversation, but none of that information was being captured. So you would have 2 tasks that would be an 8, and the 8 would have been arrived at by completely different criteria. One just lacked documentation, maybe a lack of precedence, and the other had some sort of really snarly complexity that we didn't know how to untangle. And yet none of that information was in that estimate, which made it very hard to tell how accurate that 8 was or who should even take on the task.
Yeah, I think that probably stems from the problem of different people doing the estimating than necessarily doing the task. Or maybe if you have a big backlog, you estimate, you throw it in the backlog, and then, it's several months before you actually get to it, or weeks or whatever.
Mm-hmm. Exactly.
I could see that causing problems.
Because estimation is very subjective and it's individual. So every team has their own scale, as it were. And you could have 6 teams that all use the exact same Fibonacci scale, and you can't compare their tasks. You can't compare across because they're using different criteria. And chances are they never wrote down what those criteria are. And even if they did, they're probably not going to agree with that. Well, we use an 8 means something different to us because of this unique facet of our team. And that can even happen within a project. You lose half of your team, gain some new developers. Now your estimations are completely different. So you can no longer even size to the earlier tasks in your own project.
Yeah, I've heard someone once say, like, if you change a member of your team, you have a whole new team, which I thought was a very interesting comment.
Yes, my staff mentor at Canonical, Pat Viafor, once remarked to me that every time you add someone to a team, the team's shape changes because the individual and the team both adapt to the unique attributes and traits of the individual you're adding.
Mm-hmm. Great. So quantified tasks has these multiple numbers, right? So in story points, you just have one number which fails to capture this stuff. So how do the different numbers in story points, what are they and how do they capture this nuance?
Right. So there are three facets of quantified tasks. I have to clarify that up front. So there's a triad of numbers that are related to planning, and then there's a pair of numbers that are related to stability and bugs, and we can come back around to those. But the triad of numbers that I'm focusing on here for estimation are distance, friction, and relativity. The thing to understand is that you capture these numbers individually, but then there's also a very simple formula that is used to derive an energy point score, and energy points is the drop-in replacement for story points. So I'm going to come back around to energy points. The three numbers, though, are valuable even by themselves. They're the kind of the three ways of measuring the effort involved in a task. One of the challenges with story points is that we're measuring it relative to our own skill rather implicitly. We look at it, we think, well, that would take me a day. Well, the problem is you may not be working on that. In fact, you may not even be at the company anymore by the time someone is working on that. So we can't rely on that subjective personal, this is this size to me because of my skill level. We have to factor our skill out of this. And that's why I have these three specific numbers. Distance is roughly how long would it take me to complete this task if I knew everything. And that little clause is what takes subjective skill differences out of the equation. If you knew everything, how long would it take you to complete this task? This separates out raw work, fingers on keyboard, just implementing, from closing any sort of knowledge gaps that you may have, either as a developer or as a result of having to invent. So it isolates just that raw work variable out. And it's always measured relative to your sprint. So whatever size sprint, whatever size development cycle your company uses, that is what distance is relative to, because time is not really the point here. It's raw work that you're measuring. The second number is friction, which is how many resources, or I guess you could say what lack of resources is there to help you complete this task. Again, it's not how much do I have to learn? It's what resources exist, because it's going to take significantly less developer effort to complete a task that involves reading some well-maintained documentation and a tutorial versus having to read between the lines of an API document that hasn't been maintained in 6 years and inventing the rest. There's a massive difference in the amount of work involved there, the amount of effort involved, which, by the way, measuring friction has the upshot that it automatically surfaces all of your low-hanging fruit, because low-friction tasks are great first contributor tasks. Someone brand new to the team, someone who's brand new to the language can pick that up because there's more resources for them to figure it out. And then your more senior members can take the higher friction tasks because they're going to need that expertise to get it done. The third number then is relativity. So there's this saying in story pointing, make your best estimate, multiply by 3. And that works because that multiplying by 3 is accounting for everything you don't know. Well, how much you don't know is something you can usually figure out up front. If you look at a task, you can go, you know what, we have no idea how this tool works. This is complete invention here, and I'm not even sure this algorithm is possible in this language. Now you have some unknowns. So relativity becomes this measurement of kind of a ratio of how much you know versus how much you don't know about the task itself. How much is obvious versus how much is discovery and invention. And this becomes your multiplying factor when you create your energy points. So energy points you get by adding your distance and your friction scores, which, by the way, forgot to mention, all of these are on a scale of 1 to 5. So you add your distance and friction scores together, and then you multiply by relativity, which is, again, 1 to 5. And that is going to give you an energy point score. That score, by the way, because you're using 3 fixed and reasonably objective systems for measuring, are repeatable across teams. So that number you're getting, that energy point score you are getting, is comparable not only to every other quantified task estimated task in your project's history, but to any other quantified task estimated issue you've ever worked on. You actually can form a personal relationship to that number, which makes it now directly useful because, like for me personally, I typically can complete about 23 to 26 energy points per sprint if I know the stack. That holds true regardless of the team I'm working on. So that allows me to tell you how long it's actually going to take me to clear 6 story points. I know that. That's actually a number I can give, and that allows for better selection of work, better distribution of work, and better time estimates for the managers, because we have this score that is repeatable, it's objective, and we've recorded the factors that went into it, the amount of work, the amount of research, and the amount of innovation that's going to go into it.
So for teams that are using story points now, is dropping in quantified tasks just simply changing the way they come up with their number? Is that basically it? Like using these 3 numbers and then, or is there
basically,
more to it?
Yeah. Okay. That literally is it. And the interesting thing is, all the teams I've implemented this on and all the teams I've talked to about this have remarked that this is basically the conversation that they're trying to have about story points anyway. But they hadn't really boiled it down to those 3 questions concretely. So things wind up drifting off into different priority levels. See, this takes the question of what's more important, what do I assign more weight to in my estimate, out of the equation, thereby removing that subjectivity that varies from team to team. Because we have a formula and we have 3 1 to 5 numbers, that really constrains how you do estimations. So now estimation becomes, in a team, asking those 3 questions. How long would it take, relatively, if you knew everything? How many resources are there? Documentation, health of the code, availability of subject matter experts, yada, yada. And how much do we know versus we don't know? Those 3 questions wind up guiding the conversation during estimation. And it would sound like that should take longer than story pointing would. But in practice, it actually tends to go faster because you've now laser focused your conversation and everyone can throw out their estimates and specifically narrow in on what they maybe disagree on and find the numbers that everyone is comfortable with.
Yeah, I can imagine spending less time arguing. Yeah, I gave this a 3, you gave it a 5, why? Right? And then you could explain a lot easier.
Exactly.
Very good. So for people who are using some common tooling like maybe Jira or, I don't know, GitLab issues or whatever, or GitHub issues or whatever, do these things support using quantified tasks? Or
because quantified tasks is a fairly new method, you're not going to be able to fire up a tool and just find this like sitting there waiting for you. But most issue trackers do have some form of custom fields. Jira especially works really well with this because you can add the custom fields for distance, friction, and relativity. And I actually have instructions at quantifiedtask.org if anyone wants to follow the setup process, because Jira integrates really tightly with this. So you set up the fields for distance, friction, and relativity, and then you set up a Jira automation task. And once you fill in those 3 fields, the Jira automation task is going to run, and it will go ahead and calculate your energy point score off of those and automatically fill in that field for you. And I actually used this on a team earlier this year that I was leading, and it worked very well for us because it would take us usually about 30 seconds to estimate a task, and we would just fill in distance, friction, relativity from the drop downs, and then it would propagate our energy points, which would then show up throughout the system as a story point would, as a story point estimate would. If you're using something that doesn't have custom fields, it does get a little bit more challenging. So like GitLab issues, unless you're paying for the ultimate tier, you're not getting custom fields or any of that jazz. You're not even getting story pointing. So in that situation, if you're finding yourself limited by a lack of custom fields, I like to use labels in that situation. So GitHub, GitLab, Discourse. I actually have used Discourse as an issue tracker. It actually works pretty well. But at that point, you create tags for your different distance, friction, and relativity. You just create tags for each of them, tags or labels. But above all, if you are missing everything, if you have no way of making this work, you can actually still use whatever. If your thing just has a spot for story points and you have no way of adding custom fields, just put the estimate at the top of the description. Just put in, and there's an official notation for this. So like you can put like D3, F2, R3, which would be distance 3, friction 2, relativity 3, equals, and then whatever your energy point estimate is, and then copy that estimate into your story point field.
Yeah,
and
there has to be a place
well.
to put a description or something in there somewhere. At
Yeah,
least
exactly.
that it's still there captured somewhere.
Exactly. And really that's the point.
Yeah, so when you look at the one number, then you actually can figure out how it was derived, I think. That would
Exactly.
be useful. Yeah, which goes back to the point you mentioned at the beginning. We've got 2 8s. Well, why are they 8s?
Yeah. And the other upshot of capturing this information, by the way, is that it actually puts stakeholders, decision makers, et cetera, especially non-technical decision makers, in a position where they can actually be useful now. Because managers try to make sense of story points. And again, they tend to do that by equating it to time or to budget or whatever. But because energy points comes from 3 clearly defined scales, and those estimates are actually captured in the task, what winds up happening is that if you'll have, say, a manager who's saying, how can we speed up development? Well, now you can actually look at those numbers. You can actually look at, oh, you know what? The reason things take us so long is because our friction is routinely very high, but we don't have a lot of seniors on the team. We need more seniors in the technology we're using if we're going to move faster, or else we need to bring down the friction. Maybe we need to use some technology that's better documented. So it gives a starting position to have a conversation with your non-technical contributors, because they don't have to understand code or agile to understand how quantified tasks is working. It's documented, it's written down.
Yeah, those are really good examples. I quite like that. So one thing I see teams that are using story points, they often like to talk about velocity. What are your opinions on that? How does that work with quantified tasks? Is that even a useful metric?
It can be, and I got to thinking a lot about the value of velocity and quantified tasks on the heels of that rather controversial McKinsey article about measuring developer productivity, because one of the reasons I'd come up with quantified tasks in the first place was because there was no way of measuring developer productivity, because there was no way of measuring how much energy went into a task. So because you can't measure the work they're doing, you can't measure how productive they are. It's kind of a bit of a QED. So if we understand the amount of energy that goes in, then it's easier to understand how productive developers are being. The limiting factor in software engineering is not time. It is not money. It's rarely even technology. It is always developer energy. If you're out of steam, no amount of money, time, or additional team members is going to increase the amount of energy you have. You're done. You are out of energy for the week. This is why, by the way, the saying never ship on Friday is so wise. It's not because there's something special about Friday. It's because people are out of steam. They have been working all week. Their brains are tired. Therefore, they're more likely to make mistakes. So because energy points is directly linked to developer energy, then velocity becomes a useful way of measuring productivity, in that you are seeing how much energy your developers are actually putting into things, how much they have available to them. You can start budgeting because you know how much is available to you. Your developers can say, well, I usually get done with about 20 story points a week. Well, now you have a budget and okay, I can't throw 40 energy points at them and expect them to get it done. They're going to be out of steam. They have 20 energy points on average to work with. So those numbers become a way of looking at the amount of energy your team has over time. And if you're noticing a sudden drop-off in productivity, a sudden drop-off in velocity, now the question is, where's the developer energy going? Is it going into meetings? Is it going into non-coding related stuff? We know what their budget is. They're consistently way below budget right now. What happened? Why is it there? And that becomes the beginning. It's always the beginning. Numbers are never the end of the conversation. They're only the beginning of a conversation. But it becomes the beginning of a conversation. I see you're trending way below your average. What's going on? Where's the energy going? How can we help you?
Yeah, those are very useful conversations. So the next question I have is, and we've kind of hit on this a little bit, but like, I guess, what problems have you noticed that Quantified Task Solve that StoryPoints just like miss? And I think part of it is what we just talked about, but are there other things that you've noticed?
The main thing really just is that repeatability, moving the conversation into developer energy. I guess that's the biggest thing, is that StoryPoints, because it doesn't mean anything. And when I say that, I'm actually quoting some Agile practitioners who say, well, the nice thing about StoryPoints is they don't mean anything. Well, that doesn't make them particularly useful for planning. So I can't just tell you that my window is 47 flurbs wide. That means nothing to you. You can do nothing with that information. If I told you it was, say, 3 feet wide, now if you were going to fix my window, that would mean something. So if you're going to use a measurement, it needs to mean something, and it needs to mean the same thing to each person that's using that thing, that's using that measurement. It needs to not be changing from company to company or team to team or individual to individual, because then you just have chaos. Imagine if every engineering firm had their own tape measure, their own proprietary tape measure with their own proprietary measurement system. The chaos that would ensue. We would never be able to build anything. So the unitlessness of StoryPoints really works against, not only because it's not useful at that point, but also human beings, especially managers, live to derive meaning out of things. Humans don't like things that mean nothing. They assign meaning, and if there is no meaning, they will invent a meaning. So StoryPoints is begging to be misunderstood. That's the problem. It is crying out to be interpreted, but when there's no interpretation, every interpretation a manager is going to come up with is going to be wrong. So by having a system that has a meaning, then that is also going to resist misinterpretation, because you can't pretend energy points is anything other than measuring developer energy, because that's what it is. It's not going to as readily be misunderstood as a time commitment or a budget, because it is about developer energy, and that's capped. But since managers like time and money, because they're the things they have control over, this number becomes useful to them, because they can go, we're not moving very fast, but that's because this team doesn't have enough energy to go faster. If we added a couple of senior engineers to this team, maybe they would. Or if we removed some meetings from their calendar. Or if we put some money into finding ways to improve how much energy they have available to them, maybe shorter working days, for example. And so they can start using the tools they have, money, time, policy, to try to optimize how much developer energy is available, which is honestly what we've been wanting them to do all along, right?
Yeah, that's great. So my next question is, can you talk about a specific project where they were using StoryPoints and you came in and you switched over to Quantified Tasks, and how did that go? And did you learn any lessons there?
Yeah, I'm trying to think. What's funny is I can think of a couple of projects where people didn't want to switch. And this was a little bit earlier on. I actually remember one project where I had proposed this because the problems they were running into was chiefly that their estimates were both inaccurate and useless. And I proposed this, and this was actually the person who said to me, well, I like StoryPoints because they don't mean anything. And I'm like, what? And I think the problem there becomes when StoryPoints become the end instead of the means. And that was literally the case here, because this person was actually publishing their velocity charts online publicly as marketing data, as a way of marketing their company. I'm like, no, you don't do that.
Well, that's odd at the same time that he says it's meaningless, which is just weird.
Well, it's meaningless, and so he was able to artificially inflate the numbers and make it look like they were more productive than they actually were by misrepresenting velocity. So
Must be
I think
a consulting house or something, right?
Yeah, it was, and it was like it was scary. So I think one of the interesting sides of this is because quantified tasks is not arbitrary and it's really hard to manipulate because of its limitations, its deliberate limitations. Because it's really hard to manipulate inches, for example. An inch is an inch. You can't really manipulate that. So I think it helps expose some zombie Scrum mindsets where they're using Agile for things other than Agile. And I think it's where you see some resistance. The team where I rolled this out, I actually was able to roll this out at the beginning of the project. So it's not like we switched from story points to energy points, but everybody there had been using story points up to that point. So they come into this project with a story point mentality, and everyone's a little bit skeptical. It's like, this is weird. I'm used to Fibonacci numbers. Why are we doing this? But they agreed to give it a try. And within one sizing session, one planning session, every single person was sold. Because it's like, I actually know what this number means now. The funny thing is energy points follows almost the same curve and range as the Fibonacci numbers. So you could drop it in and just at a casual glance at your board, you would not notice the difference.
So along those lines, when we talk about pushback, do you tend to get more pushback from management or from developers, or is it fairly equal?
I think it's fairly equal because managers want information. And I remember one manager saying, I don't want to use this because I would rather people write better descriptions. And I was trying to explain, well, people aren't going to write better descriptions because developers are lazy. Sorry. That's what you literally pay us to do is to be lazy. We weaponize our laziness into saving the company money. That's why we're here. That's why you hired us. So developers are lazy. They hate writing things down. They hate documentation. They hate writing good descriptions on tickets. I rarely see good descriptions on tickets, any team, because no one wants to waste the time. Right? At least they view it as a waste of time, so they don't do it. So part of this is about limiting how much writing they actually have to do by capturing the things that they should capture every time. So I think that's where this manager didn't understand where this would help, because he just wanted more text and wasn't really thinking about, well, what are we capturing? Developers, I think, are generally pretty open to it unless they are members of the cult of Agile, as I refer to it. Because there's Agile methodology and then there's the cult of Agile. And the cult of Agile is where it becomes a religion. Like I mentioned earlier, it is the end in itself. Like the outcome of Agile isn't the point. Agile itself is the point. We do stand-ups because we do stand-ups. We do retros because we do retros. And no one's thinking about the outcomes anymore. And where you have that, there can be a lot of resistance as well, because this goes against the rituals. It's going to the same end. In fact, it's getting closer to the end that you want. But because it requires a bit of a departure from kind of the religious adherence to, Fibonacci numbers or t-shirt sizing or what have you, there can just be some lack of familiarity kind of resistance because people don't like new things. They don't like change. But beyond that, honestly, I haven't really run into much resistance beyond that, because if people are doing story pointing for the goal of sizing, then this just becomes a way of doing that quicker and more efficiently.
So you mentioned something earlier about how quantified tasks can be used for planning and estimation, but also something to do with bugs and volatility and stability. Do you want to comment on that?
Yeah, absolutely. So leading into this, one thing I want to point out about quantified tasks is that every number in there, at least every number you set directly, is a 1 to 5. Energy points is a calculated number so that it isn't constrained like that. But every scale you set is a 1 to 5 scale. And 5s are always special, by the way. In this system, a 5 is always special because it means that there's something you need to pay attention to. So distance, it means this is going to take longer than a sprint, break it down. Friction means we know nothing about this. Like, this is just way too complicated. We're going to need to spike it to reduce some of the lack of resources we have. Relativity 5 means this can't be completed in the history of the universe. It's just we know nothing. We know absolutely nothing. This is a black hole. So 5s are always special. And I bring that up because that applies to the volatility as well. So I can't take credit for the idea of volatility. This actually goes back to a gentleman I was talking to on the dev platform, dev.to. He wrote a very interesting article about that you could predict the stability of a project by how long a bug remained uncaught. Because if you think about it, we catch a very small fraction of the bugs that are in our project. So if you catch 10 bugs, then it's safe to assume there's at least 10 more floating around. The reason that you can determine this from how long a bug has been living in your project is because it indicates when you have a quality control gate, as I like to call it, that has failed. Because we have these throughout the software development lifecycle. You have the design process where there should be some discussion going on as you're writing the requirements, etc. There's the coding process. You should have code review and static analysis tools and tests. QA should have additional testing, should have additional linters and what have you. And then you finally get to production. And then by that point, you're relying on your users to catch it. So if you have a bug that appears in design and makes it to production, what that means is that your requirements review failed, your static analysis tools did not catch it, your testing didn't catch it, your linters didn't catch it, your CI failed to catch it, your manual review failed to catch it, and now it landed in your user's lap. So you have multiple points of failure at this point. So using that same 1 to 5 strategy, what you wind up doing with this is that when you report a bug, you only record 2 numbers. And again, they're 1 to 5s. You record 2 numbers. The origin, which is what point this emerged, which is surprisingly easy to figure out. And your COT, which is when it was first detected. And you subtract those 2 numbers, and the resulting number tells you which quality control gate failed. And the higher that average volatility score is, because when you subtract the 2, that gives you volatility, the higher that average is, the more failures in your quality control system you have, and the more likely you have bugs that are making it into prod.
Okay, so for these numbers, like what does the 1 to 5 represent? 1 is like it appeared in the design phase, and then 5 is like my users caught it. Is that kind of the scale? Okay.
Exactly. So they map to the software development lifecycle. So 1 is planning, 2 is design, 3 is implementation, 4 is verification, and 5 is production.
Okay.
So if you catch a bug at the same phase it originates, you're great. You have 0 volatility because bugs are always going to show up. But that means your quality control is flawless, or at least darn near close. But if you have a high average volatility, then that is going to tell you that you got no quality control and all your gates have failed, and any mistake you make in planning is going to make it all the way out to the users.
Huh. That's interesting.
You can also combine this with one of the planning metrics, impact, which I haven't talked about yet. But you can also combine this with impact to tell you also the kind of the severity that you're looking at. Because COT minus origin times impact is going to give you this number. And actually, that's the actual volatility score. That's going to tell you not only if your quality control gates are failing, but it's also going to tell you how serious the bugs are that are manifesting. Because, honestly, if you have a bug that manifests as a button that is 1 shade of blue off, that is nowhere near as important as the bug where the user presses save and it deletes everything in the record. So that impact also factors into the volatility score.
Okay, so if I understand this correctly, it's almost like a risk score. The first number is like the likelihood of something getting through, right? Because that's how long it existed. And you're multiplying that by the impact. So it's very much like a risk. If you take risk, it's like probability times impact, kind of, or probability times consequence.
Exactly. Yep. So by the time you take the average across all the bugs in your project, which Jira can do this, if you take your average across all your bugs, if you have a solution volatility, that's what that average is called, the solution volatility. If that's greater than 10, basically your servers are on fire. You have some major problems, and you should probably stop shipping features and figure out what the devil is wrong with your pipeline, because nothing is reliable at that point.
Okay, so I have one last question. Is there any time that you wouldn't recommend this approach? So you'd recommend like just sticking with story points?
I have to be totally honest. I don't think I would ever recommend sticking with story points, because that would be like recommending someone measure everything relative to their own foot versus using a ruler. That said, this is not a panacea. This is a piece of the puzzle, but it's never going to be the overarching solution to everything and it fixes all of your problems. And that's not because quantified tasks is somehow insufficient for any given situation. It's because it isn't the whole solution. It's a piece of a solution. If an engineering firm has lots and lots and lots and lots of problems with quality control and planning and how they do things, but they switch from measuring everything relative to the foreman's foot to using a ruler, that's still an improvement, but it's not going to really fix the rest of the problems in the organization. So it's like with Agile in general. A lot of companies erroneously think you can just throw Agile ceremonies at a project and it'll magically fix all the problems. But what has to change first is the mentality, not only of the developers, but also with managers, of switching from this waterfall technique of let's just plan everything and make everything predictable and all of that, to switching to an iterative approach of Agile. And then Agile is useful. But without that mindset shift, it's really not going to do much, if any, good. In fact, it'll probably do harm. And quantified tasks, the same thing. Yes, you can implement it in place of story points, but if you're already doing zombie scrum, if you're already misusing Agile, this is not going to fix all of your problems. So I think teams need to look very carefully at why they're having problems and really take a hard look at where the mindset needs to shift, and then use this as one of the tools to help shift mindset, help shift approach. But it needs to be secondary to that introspection, not first.
Okay. Now, would implementing qualified tasks then, though, perhaps help like indicate some of the problems? Like it'll point out some of the problems? Or is that...
It can in theory, but I think, again, if teams are using, like I mentioned earlier, it can indicate when you're using zombie scrum because there's this general resistance to it. But it can be misused like anything else can be misused. Goodhart's law still stands, which is that as soon as you make a metric a goal, the metric ceases to be useful. So if a company were to adopt quantified tasks and suddenly make lowering the energy point estimates on everything to be the goal, then this is not going to be useful because Goodhart's law is going to completely undermine it. And estimates are still just going to be a meaningless exercise in futility as opposed to a planning tool. So you still have to look at where your mindset is off as a team, as a company, before you start throwing solutions at it. But I think it's true as a rule. Like, we never fix a car by throwing a wrench at it. You can throw every wrench in your toolbox at a car, and it's not going to fix the car if you haven't identified what the problem is. Once you know what the problem is, wrenches are very useful. And in fact, it's probably impossible to fix many problems without a good wrench. But if you don't know what the problem is, the wrench is just going to get in the way.
Okay, yeah, that's a great explanation. Thank you very much. So if people want to learn more about this, there is a website, right? quantifiedtask.org. Is that correct?
Yes. Yep,
Perfect.
Absolutely. So I try to post articles periodically on how to implement this. But if you go to that website, right along the top are the tabs for planning, estimation, and stability. And that explains how to use each section of quantified tasks. And don't feel like you have to implement this whole thing right now on your team. One of the cool things about this is that you can just take one piece of this, one part that your team is going to find useful, implement just that, and you're still going to get value out of it. Don't feel like you have to rebuild your entire issue tracker tomorrow to implement this. You can go gradually. I really recommend using this in the context of that iterative, agile approach. Let your team take ownership of this, because if you just enforce it from the top, no one's going to like it.
Yeah, that's a very good principle to live by. So thank you very much, Jason.
Thank you.
For Software Engineering Radio, this is Sam Taggart. Thanks for joining us.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.